Good morning, student. Myself Priyanka Hande, and I am going to revise today unit number 2, that is Laplace transform. So we have already completed unit 1, 2, 3 before lockdown, and that we are revising unit 1 and 3rd is already revised by our math faculty. So I will be revising unit 2, that is Laplace transform. So shall we start? So unit 2, it is Laplace transform. So as you know, we have already done this unit in our regular class in detail. So today I'm going to revise this once again. So in very brief, okay, so it is the Laplace transform revision class. So first, what is meant by Laplace transform? Yes, you already know. So let's start with definition. Let f of t be a function defined for all positive values of t, that is all values of positive values of t, that is t is greater than or equals to 0, and is denoted by, and it is denoted by L of f of t. This is one notation, or f bar of s, or capital F of s. So these are the notations. Okay. So let f of t be a function defined for all positive values of t which is greater than or equals to 0, and it is denoted by L of f of t or f bar of s or f of s, and defined as the Laplace transform. So we are finding Laplace transform of this function of t. So L of f of t, and it is defined as, it is defined for values of t which is greater than or equals to 0. So we take the integration from 0 to infinity. Okay. So 0 to infinity into the function is e to the power minus st into f of t dt, provided this integral is exist. Okay. And here this s is here a parameter which may be real or complex. Okay. So when you integrate, so here we have this function, that is integrand. Your integrand is e to the power minus st into f of t. So it is a function of s and t, right? So when you integrate and substitute the values, so you get, it is a function of s, so which may be denoted by f bar of s or f of s. Okay. So this is the definition of Laplace transform. Now we see, using this definition, we find out the Laplace transforms of function. Okay. So before going to that, first we see one property that is called linearity property. So you already come across this property in your PUC level, linearity property. Yes, you are applied for integration also and differentiation also, right? So the same property here also we have linearity property. So for any function f of t, for any f of t and g of t whose Laplace transform exists, and any constant say a and b Okay, so suppose there are function f of t and g of t, which is the function of t associated with the any constant a and b, then Laplace transform of this function which is associated with a and b can be defined as, that is, Laplace transform of a into f of t plus b into g of t. Okay, so here we have a function f of t and g of t which is associated with some constant, that is a and b. So in that case, how to take Laplace transform of this? So that can be written as, so what we do, yes, you know already you have studied this in PUC, yes. So by the integration and differentiation, right? So here for what we do, we keep a constant as it is and we take Laplace transform just function of t. Okay, so it is L into L of f of t plus, similarly plus second function we have, so it is b will be taken out and we take, so it is b into Laplace transform of g of t. Okay, so this is a linearity property which we are going to use while solving the problems. Okay, now we see Laplace transform of some functions. Okay, so there are some functions which are going to repeat again and again. So there are some standard functions. So first we find out Laplace transform of such functions. Okay, so I write here Laplace transform of elementary functions. Okay, so Laplace transform of elementary functions. Now first one, we start with first one. Find Laplace transform of a, where a is constant, So where a is any constant. Now how to find Laplace transform of this function? It is a constant. Okay. Now by the definition of Laplace transform, we have Laplace transform f of t. It is defined for all the positive values of t, that is t is greater than or equals to 0, right? That's where the integration limits are 0 to infinity. Okay, so we make use of that definition. So by definition we have Laplace transform of f of t is equals to, it is the integration from 0 to infinity e to the power minus st into f of t dt. Now here given question is, we have to find Laplace transform of a constant. Okay, so here that function is a constant function. Okay, so this a is a constant, means here f of t value is a. Okay, we have already done this in class, right? So now just substitute the value of f of t here, that is a. So therefore Laplace transform, so which imply Laplace transform of a is equals to, so what will the changes in the definition? So here it is integration from 0 to infinity e to the power minus st, f of t is here, what is f of t? It is a into dt. Now we need to integrate this one. So after integrating and substituting, the result what we get, that will be a function of s. Okay, so that is equals to, now here it is a constant, a is a constant here, see the integrand, here we have only one function of t, that is e to the power minus st, and a is a constant. So again, here again linearity property we can make use here. We have already done this PUC, that is integration. So a into integration from 0 to infinity e to the power minus st dt. Okay, so that is equals to a. Now what is the integration of e to the power minus st? Yes, it is e to the power minus st upon minus s, because we are integrating with respect to t. Okay, so here s will be acting as constant. Apply the limit 0 to infinity. Now when you simplify this, so here a upon minus s I take out common. Okay, so only to this function which contain t I apply the limit. So it is equals into e to the power minus st. Okay, t is replaced by infinity, so it is e to the power s into infinity, that is again infinity. So e to the power minus infinity value is 0 minus, and e to the power lower limit minus lower limit, e to the power 0 is 1. So minus into this minus become plus. So answer is A by S. Okay. So what is Laplace transform of any constant? It is that constant divided by S. Okay. So Laplace transform of any constant, that is Laplace. Therefore Laplace transform of any constant is equals to A divided by S. Okay. So this is how you have to apply the definition to find Laplace transform of any function. Okay. So next we go for the next. So next is similarly we can find out e to the power 80. Second is find Laplace transform of e to the power 80. So what will this? So by the definition of Laplace transform, it is defined as, it is integration from 0 to infinity e to the power minus st into e to the power 80 dt. Now simplify this. So base are same, so we add the power. So 0 to infinity, integration from 0 to infinity, it is e to the power. So how I write this? I take minus sign here, common. So inside the bracket I write s minus a into t. Okay, so how you are simplifying this? So it is e to the power minus you are taking out, minus into s minus a into t dt. Okay, now integrate. It is equals to, it is integration from, so it is, what is the integration of e to the power minus of s minus a into t? It is e to the power minus s minus a into t divided by minus of s minus a. Now apply the limit, both upper and lower. So after substituting the limit we get, so here I take 1 upon minus of s minus a, it's common term. Okay. Now I apply the limit to only the numerator, that is e to the power minus s minus a into t. So when you apply the limit, so due to this infinity, this exponent become infinity, and e to the power minus infinity is again 0, minus e to the power 0 is 1. So again minus into minus become plus, we get here 1 upon s minus t. So Laplace transform of e to the power 80 is equals to, it is 1 upon s minus t. So similarly you can find out Laplace transform of e to the power minus 80. So what will be this? Yes, it will be 1 upon s plus a, right? Okay, so we already done this. Okay, next go for third, Laplace transform of sine of 80. Now we take a trigonometric term. So what will be Laplace transform of any trigonometric, which is sine 80. So it is equals to, okay, again by the definition it will be defined as integration from 0 to infinity e to the power minus st sine of 80 dt, because your f of t is nothing but sine 80. Okay, now we need to integrate this. So can you easily integrate this? Yes, can you apply? So if you apply Bernoulli's rule of integration or integration by parts, what will get? The function will repeat again and again. You won't get the finite result there, right? So what we do? So in such cases we go for the substitution or some standard formula, right? So yes, so we have one standard formula which is similar to this. Okay, what is that? So under note I write down. Okay, note. So we have integration of e to the power ax into sine of bx dx. Yes, what is this? Yes. So this is defined as, yes, it is defined as, it is e to the power ax upon a square plus b square into the bracket a into sine bx minus b into cos of bx. Okay, so we have this standard formula. So making use of this, we can integrate this integrand. Okay, So now we apply the same formula to this term. Okay. So after applying this, what we get? So it is the integration here. So here a value is minus s and b value is a. So when you integrate this using this formula, we get e to the power minus st upon minus s square, that will be plus, right? Plus s square plus b square. What is b value here? It is a. So it is a square. Okay. Into the bracket. A. What is a here? It is minus s, right? Into sine of 80 and minus b. B value is a. So minus a into cos of 80. Okay. Now apply the limit here. 0 to infinity. Okay. Now substitute the limit. Now here, which term you are going to substitute the limit? The term which containing t, right? So here see this exponential term. So still it is having means it is having t. So we need to substitute here and even this term. Okay. So only one term is free from one term is free from t, that is 1 upon s square plus s square, which is a constant. We take it as constant. We take aside. It is 1 upon s square plus a square. Now inside the bracket, so we have e to the power minus st minus s into sine 80 minus a into cos 80. Now when you apply the upper limit to this, what will happen? Okay, so here see, when you apply the upper limit, you are replacing t by infinity. So it is e to the power minus s into t into infinity. T is replaced by infinity. So minus s into infinity. So s into infinity, again it will be infinity. So it is e to the power minus infinity. E to the power minus infinity is 0. 0 here again, if you apply t replaced by whatever it is, so it will be, so we get here again 0. So 0 into this something will be 0. Okay. Next, similarly minus lower limit e to the power 0. T is replaced by e to the power 0. Here sine 0 is 0. Again cos 0 is 1. But it is minus 8. Minus time a. So minus a. Okay. So what you get here? It is minus a into plus minus a become plus a. A divided by s square plus a square. So it is Laplace transform of sine 80. It is a divided by s square plus a square. Okay. Now similarly, what will be Laplace transform of cos 80? Yes, we have already done this. So it is Laplace transform of cos 80. Cos 80 is, so similarly, we can find Laplace transform of cos 80. It is s upon s square plus a square. Okay. Okay. So you do this. We have already done this in class. Okay. So just apply the definition. This is a revision. Okay. You recall this. So result will be s upon s square plus a square. Okay. Next. So what is Laplace transform of sine hyperbolic of 80? Okay. Now here we have a hyperbolic function. It will be different. Okay. So if you apply here definition, what will happen? So inside the integral, you have the integrand e to the power minus s into sine hyperbolic 80. So which will be tedious to simplify. Okay. So what we do? We express this sine hyperbolic function into its exponential equivalence. Okay. So we write this as Laplace transform of sine hyperbolic 80. I express it into its exponential equivalence. Okay. So it will be e to the power 80 minus e to the power minus 80 divided by 2. Okay. Now it is easy to evaluate. Yes. Yes. So it is equals to 1 by 2. Again you can make use of linearity property here. So if there is any function f of t which is associated with some constant, so in that case we go for linearity property. How? By taking that constant outside and applying the transform only to the function f of t, right? So here 1 by 2 will be taken out by applying the linearity property. So 1 by 2 I take out, and inside the bracket I write Laplace transform of e to the power at. Okay, now I separate this. Even here we have minus sign, minus Laplace transform of e to the power minus 8. Okay, now we take its Laplace transform. Now it is one of the elementary functions that we have already done. Yes. What is Laplace transform e to the power 80? Yes, it is 1 upon s minus a. Similarly, what is e to the power minus 80? It is 1 upon s plus a. Now we make use of that elementary function. So 1 by 2 into the bracket. Yes, this is how you have to use the elementary functions. Okay, results. So it is 1 upon s minus a plus minus 1 upon s plus a. So Laplace transform e to the power 80 is 1 upon s minus a minus Laplace transform e to the power minus 80 is 1 upon s plus a. Now simplify this, take the LCM. Okay. So these are very linear. So take the LCM. If you take LCM, what you get? It is s square minus a square denominator. In the numerator, it will be, so here s plus a and minus of s minus a. That will be minus s plus a. Right? So this minus s plus s get cancelled. We get here what you get? It is equals to 2a, right? 2a divided by 2 into s square minus a square. So again this 2 get cancelled from both numerator and denominator. So we get here a upon s square minus a square. Okay. So here s is greater than a. S should be greater than a. So it is Laplace transform of sine hyperbolic at. It is a upon s square minus a square. Now similarly you can find for cos hyperbolic at. Yes, we have already done this. Recall that result. Yes, what is Laplace transform of sine, cos hyperbolic at? It is s upon s square minus a square. Okay, so I write here similarly. Similarly, we have Laplace transform of cos hyperbolic at as s upon s square minus a square, provided s is greater than a. Okay. Now there is one more elementary function. Okay, that is if the function is, if f of t is t to the power n. Okay, so let us see what will be its Laplace transform. So Laplace transform t to the power n. When the function is t to the power n, what will be its Laplace transform? So how to take its Laplace transform? Again by applying the definition. Apply the definition. What it will be? It is integration from 0 to infinity e to the power minus st, right, into f of t. So what is f of t here? It is t to the power n. Okay. Okay. So we are finding Laplace transform t to the power n. So by the definition of Laplace transform, L of f of t is, it is integration from 0 to infinity e to the power minus st into f of t dt. Right? Now here f of t is t to the power n. It is a function of t, right? And it's t to the power n. So in that case, how to take Laplace transform of such functions? So Laplace transform of t to the power n is equals to, it is defined as integration from 0 to infinity e to the power minus st. F of t is here t to the power n dt. Now see the integrand. Can you integrate this easily? Yes? Can you integrate this easily? This seems a bit difficult, right? So in such case, we go for some standard formula. We try to compare with some standard formula, or we go for some substitution. So is there any standard formula similar to this? Yes? So what we do? We go for some substitution method. So what substitution we take? So here we go for putting est equals to x. Okay. So we put here st equals to x. Right here one more time. Put s into t equals to x. Okay. So when you differentiate this, so what it gives you, it will, so just differentiate, so s will be constant, keep as it is, s into dt equals to dx, right? So when you differentiate this, we get s into dt equals to dx, or which imply dt equals to dx by s. Okay. So whenever we are substituting, we have to change the limit also, right? So here limits are 0 and infinity, which is defined for t, right? It is defined for t. So here now we are converting this function t in terms of x, right? We are getting now, we are bringing this function in terms of x. So we have to define the limit for x. Okay. So how? So here we already taken your substitution st equals to x. Okay. So making use of this only. So when here t equals to 0, so this is the given limit when t equals to 0. So when you put t equals to 0 into this substitution, what will the x value? So which implies x equals to also 0, right? Similarly, when t is equals to infinity, so which implies x is equals to is also infinity, right? So here limits are same. Okay. Now we make use of this substitution in this function, in this integral. Okay. Next, Laplace transform of t to the power n is equals to, therefore Laplace transform of t to the power n is equals to, it is integration from 0 to infinity, okay, e to the power minus st. St what we have taken, it is a x. So we replace now this st by x. So we take it as e to the power minus x into f of t. F of t is t to the power n. We have taken st equals to x. So what will be t? Here we have st is equals to x. So what will be t value? It will be x divided by s, right? So write that t as s x divided by s raised to n. And dt, what is dt? Dt is dx by s. That dt is dx upon s. Okay. Now simplify this. Integration from 0 to infinity e to the power minus x. Now open this bracket. We have the power n. So numerator we have x. So it will be, so when you open the bracket, it will be x to the power n upon s to the power n. Okay. And here we have s to the power 1 in the denominator. So this, what will be s power then? It will be s to the power n plus 1. Okay. Into dx. Okay. Now this is equals to, now again that 1 upon s to the power n plus 1 is constant, because now we have integrand with respect to x. Okay. So we need to integrate this with respect to x. So their s term will be taken as constant. So that take out of the integral sign. So it is 1 upon s to the power n plus 1 into integration from 0 to infinity e to the power minus x into x to the power n dx. Okay, this was the function. Now what is this one? Integration from 0 to infinity e to the power minus x, x to the power n into dx. So there is one function called as gamma function, which is defined as so by the definition of gamma function, okay, integration from 0 to infinity e to the power minus x into x to the power n dx is equals to gamma of n plus 1. Okay, so this integral is nothing but it is a gamma function, and which is denoted by gamma of n plus 1. So what I do here, I replace this integral by the gamma function. Okay, so I write this, that is Laplace transform. Therefore the Laplace transform of t to the power n is equals to, it is gamma of n plus 1 divided by s to the power n plus 1, and it is true for n is greater than minus 1. Okay, and this result is true for n is greater than minus 1. Now suppose n is a positive integer. Okay, so in that case what will happen when n is a positive integer? So this gamma of n plus 1 will be equals to n factorial. So when n is positive integer, gamma of n plus 1 is equals to n factorial. Okay. So when n is a positive integer, gamma of n plus 1 is equals to n factorial. So now how you write Laplace transform t to the power n? It depends on the value of n. Okay. If n is a positive integer, we have the result. It will be equal to n factorial upon s to the power n plus 1. And if it is a negative or fraction, then that is when n is greater than minus 1, then we have it is equals to gamma of n plus 1 upon s to the power n plus 1. Okay, so the same result I write. Laplace transform of t to the power n is equals to n factorial upon s to the power n plus 1 when n is positive integer. Okay, and this Laplace transform t to the power n is equals to gamma of n plus 1 upon s to the power n plus 1 for n is greater than minus 1. Okay. Yes. So I think all of you recalled this. Yes. Okay. So these are 7 elementary functions whose Laplace transform we have seen now. Okay, and this results we are going to use while solving the problems. Okay, now shall we start the problem? Yes. Yes. So we have already done all the problems based on this elementary function. Okay, so one, two I take just for one more time. I just glance 1, 2 examples. Okay, so first example I take mixed one, so you can understand the difference between all the elementary functions. Okay, so first problem, find the Laplace transform of first problem. It is e to the power 2t plus 3 into e to the power minus t plus 5 plus cos of 3t plus 2 into t. Okay, so this is the problem. Now you have to take, so it is all are functions of t except that 5 also it is a function, but it is a constant function here. Okay, so now first what we do, first we apply Laplace transform to this entire function. So they are asked to find Laplace transform. So we start with, okay, Laplace transform of the given function, that is e to the power 2t plus 3 into e to the power minus t plus 5 plus cos of 3t plus 2 into t. So this is the given question, find Laplace transform of this function. Now first step, so first we separate this all term because all terms are not same, they are not only exponential or constant. Okay, so it is a mixture of a trigonometric constant and exponential term. So here we go for linear property. Okay, so we separate this. Okay, so how we separate? Laplace transform of e to the power 2t, okay, plus 3 into 3 is the constant here, so 3 into Laplace transform of e to the power minus t, okay, plus here the function is only constant term, means f of t, that function itself is a constant function. So we take Laplace transform of 5, okay, plus Laplace transform of cos of 3t and plus Laplace transform 2 into t. Okay. Now here you can see the first term, it is e to the power 2t. Okay, so you can just compare the elementary function first, second one result, that is e to the power 8t. It is of that form. Second, similarly, second one is again exponential term, e to the power minus t. Okay. Third one is a constant one. You can easily find out its Laplace transform. Fourth one is trigonometric term. So it's in terms of cos. So you know what is the Laplace transform of cos of 80. That is s upon s square plus a square. Right. Now here it is Laplace transform of 2 to the power t. So have you come across elementary function like this? No. Okay. So you have to bring in one of the elementary function. You can't treat this as a constant because it containing t. It is not a constant term. It is a function of t. But we don't have the elementary function similar to this, right? But we can bring this function into one of that elementary function. What is how you are going to bring this? So in POC you are already come across some results, right? So what is that? One of the result is e to the power log x, right? So what is this e to the power log x? It is equals to x, right? Yes. So e to the power log x is equals to x. Now here 2 to the power t I have. So what I write? I write this 2 to the power t into e to the power log x form. Okay, how? So I want here x value is here. This is x value, that is 2 to the power t. So how I should write this? I want to convert this into exponential form, exponential function. So this term 2 to the power t. So e to the power log of 2 to the power t. Correct? So by this result we can write this 2 to the power t as e to the power log 2 raised to t, that is equals to 2 to the power t. Again, so this can be written as e to the power, this it is apply the law of indices here, log of m square, that is 2 into log of m, right? So here similarly power is t, so I write this as t into log of t. Okay, so that is equals to 2 to the power t. So this is the result. So by result we can make the changes in our given function. Okay, now the same I write one more time, Laplace transform e to the power 2t plus 3 into Laplace transform e to the power minus t, okay, plus Laplace transform of 5 plus Laplace transform of cos of 3t plus now this Laplace transform 2 to the power t I will be writing right here plus, so this I will be writing it is Laplace transform of 2 to the power t, I will be writing it is in the form of exponential, that is e to the power t into log 2. Okay, so we have done this type of example, just I am recalling one more time. Okay, now so this is in bracket, you can write this side. Okay, now continue to the same. Now this is equals to RHS side, this is equals to, now what is the Laplace transform of e to the power 2t? It is 1 upon s minus 2. So now you know now what is the Laplace transform of this all this elementary function. So go on writing that. That is 1 upon s minus 2 plus 3 into what is Laplace transform e to the power minus t? It is 1 upon s plus 1. Okay, plus Laplace transform of 5, that is a constant, is 5 upon s. Then Laplace transform of cos of 3t is it is s upon s square plus 3 square, that is 9. And plus what is Laplace transform of e to the power t into log 2? That is 1 upon s minus log of 2, because here a value is nothing but log 2. Okay, is this clear? Yes. Now similarly, so you can simplify. Okay, after simplifying you get one more step. Okay, or you can keep into this form also. Now next, take an example, find Laplace transform of 2t plus 3 bracket square. Next is Laplace transform of 2t plus 3 bracket square. Now how you solve this? How you apply the Laplace transform to this function? Is a function of t, right? So first what you are going to do? Yes, first you compare with elementary function. Is there any elementary function similar to this step? We are coming across with t to the power n, right? Only t to the power n. But here we have 2t plus 3 the bracket square. So what to be done? What is to be done? So first we express this. Okay, we first expand this. It is of the form a plus b the whole square. So first we expand this. So we know that just we have 2 plus 2t plus 3 bracket square is equals to, it is a plus b the whole square. So it is a square plus b square plus 2ab. So it is 4t square, right, plus 9 plus 12t, right. So that can be written as 4t square plus 12t plus 9. So this is the function. Now we can apply the elementary functions over this. Yes, we can apply the last one, it is t to the power n, because it is of that form and one term is constant. Now we can take the Laplace transform. Now it is easy to find Laplace transform this function. Okay, now it is in well simplified form, this function. Now we have to take Laplace transform. Now Laplace transform of given function, that is 2t plus 3 bracket square, that is equals to, it is 4 into, again here apply the linearity property, 4 into Laplace transform of t square plus 12 into Laplace transform of t plus Laplace transform of 9. Okay, now this equals to, now see first, the first term we have power of t is 2, that is here power of t is 1. So both are positive integers, right? So when n is a positive integer, so what will be Laplace transform of t to the power n? It is n factorial upon s to the power n plus 1, right? Here we take 4 into, so here n factorial, what is the n value here? It is 2. So we take 2 factorial upon s to the power 2 plus 1, okay, plus 12 into Laplace transform of t to the power 1, n value is 1, so here 1 factorial upon s to the power 1 plus 1, plus Laplace transform of 9 is 9 by s. Now simplifying this, what you get? It is 4 into 2 factorial is 2, 4 into 2, 8 upon s raised to 2 plus 1, so it is s cube, plus here 12 upon s square plus 9 by s. Okay, you can keep into this form or just one more line, you can simplify this. Okay, so s cube, here LCM will be, if you simplify means you go for taking this LCM, so it is s cube, here it will be 8, okay, here I write it as 9s square, okay, plus 12s plus 8. So this is the Laplace transform of the given function 2t plus 3 the bracket square. Okay, is it clear? Next example. Find Laplace transform of cos square of 2t minus 1. Okay. Now, yes. Laplace transform of cos square of 2t minus 1. Yes, how to solve this now? Is of the elementary form, elementary function? Is of that form? No. But we can bring it into that form? Yes? How? So cos square 2t minus 1 is there. We have the elementary function of the form cos of at or sine of at, right? Okay. So what we do? So this we treat as theta. So we know that what is cos square theta? Cos square theta is, it is 1 plus cos of 2 theta divided by 2. Yes? So we can write this cos square 2t minus 1 into 1 plus cos 2 theta divided by 2. Okay, where theta is 2t minus 1. Okay. Now, so write this. So therefore, the given function, its Laplace transform will be cos square 2t minus 1, that is equals to. Okay. So when you apply this result here, it will be 1 by 2, right, into the bracket Laplace transform of 1, right, plus cos of 2 into 2t minus 1. Right, this is what you get when you use this cos square theta as 1 plus cos 2 theta divided by 2. Now you can take the Laplace transform. So 1 by 2, yes. So here again Laplace transform of constant, there is that constant divided by s. So Laplace transform of 1 is 1 by s. But here what is Laplace transform this? Cos of 2, again we have here, again it is not in standard form, okay, in standard elementary function. So to bring it into that form. So how to do that? So cos of 2 into this angle is there. So first I take this, I multiply this angle with 2. So write this as cos of 4t minus 2. Okay. Now that is equals to 1 by 2 into Laplace transform of 1. So this I have to take Laplace transform plus Laplace transform of, okay, now here Laplace transform this function. Okay, it is 1 by x plus, now Laplace transform of, now it is cos of 4t minus 2. Okay, so we have cos of, if it is cos of 4t, we can directly use that elementary function. Okay, but here cos of 4t minus 2 is there. Okay, so what we do? We use the transformation formula here for cos of a minus b. So what is cos of a minus b? This cos a into cos b plus sin a into sin b. Okay, so we make use of that formula here. So we write that cos a minus b as cos a into cos b. Here minus sign means alternate will come, plus sin a into sin b. Okay, so here we have applied this formula cos a into cos of a minus b. This is because of cos of a minus b, that is cos a into cos b plus sin a into sin b. Okay, so make use of this formula there. Now, therefore, Laplace transform of cos square of 2t minus 1 is equals to this 1 by 2 into 1 by s. Okay, plus. Now you see, it is Laplace transform of cos of 4t into cos 2. Cos of 4t is a function of t, right? But what is cos of 2? It is an angle and which is a constant. Similarly, in the second, sin 4t is a function of t and sin 2 is a constant. So what we do? Again here we go for applying the linearity property. So we write this as plus cos 2 into Laplace transform of cos of 4t, right? Plus sin 2 into Laplace transform of sin of 4t. Okay. Now that is equals to 1 by 2 inside the bracket 1 upon s, okay, plus cos 2 is a constant, keep as it is. What is the Laplace transform of cos 4t? Yes, it is s divided by s square plus 16. Similarly here, sin 2 is a constant, keep aside, keep as it is. And what is the Laplace transform of sin 4t? It is a upon. So a value is here 4 divided by s square plus 16. Okay, now simplify this. So after simplifying, we get 1 by 2 inside the bracket 1 by s. Okay, so here we can write here s square plus 16. We can simplify this too, taking s square plus 16 as LCM. So here we get s into cos 2 plus 4 into sin 2. Okay, so this is the final. Next. Find Laplace transform of sine hyperbolic square t. Sine hyperbolic square t. Okay. Now how you are going to do? Yes. So first to express hyperbolic function into its exponential equivalent, then take its square. So that can be written as, that is Laplace transform of e to the power at, e to the power t, it is e to the power t minus e to the power minus t divided by 2, its square. Okay, now take a square, then go for linearity property and find the Laplace transform and simplify. Okay, so I give this for homework. Okay, so you get the answer of this is 2 upon s into s square minus 4. It is more simplified form. Okay, so this I give you for homework. It is easy. Okay, so just recall one more time. Okay. Next, find Laplace transform root of t. Now here Laplace transform root of t. Function is square root of t. Here your function is square root of t. Now how you find Laplace transform? Yes. So it is of the form, it is Laplace transform of t to the power 1 by 2. Right? That root t is nothing but it is t to the power 1 by 2. Now that is equals to, so I told, so we have two results there, Laplace transform t to the power n. Okay, so it is equals to n factorial upon s to the power n plus 1 when n is a positive integer, or else we have gamma of n plus 1 for other values, that is negative or fraction. Now here we have a fraction, that is 1 by 2. Okay, so Laplace transform of t to the power 1 by 2 is defined as here. So here this is your n value. Okay, so it is gamma of 1 by 2 plus 1 divided by s to the power 1 by 2 plus 1. Right? Now this is equals to. Okay, so here gamma of n plus 1 is equals to n into gamma n. Okay, this again we have a formula for gamma n plus 1. It is gamma of n plus 1 is equals to n into gamma n. Okay, now applying that formula to this, it is gamma of 1 by 2 plus 1. We can write here gamma of n plus 1, that is equals to n into gamma n. So here n value is 1 by 2. So it is 1 by 2 into gamma of 1 by 2. okay, divided by s to the power, here 1 by 2 plus 1 is 3 by 2. Okay, now again we have gamma of 1 by 2, it is already proved result, gamma of 1 by 2 is equals to root pi. So this result we are going to use here from the gamma function. Okay, so gamma of 1 by 2 value is equals to root pi. So here we replace that gamma 1 by 2 by root pi. So we write this as it is root pi divided by 2 into s to the power 3 by 2. Okay, so gamma, what is the Laplace transform of root t? The Laplace transform of root t is, it is root pi divided by 2 into s to the power 3 by 2. Now similarly, if I change that root pi to similarly, we can do this step example also, Laplace transform of 1 upon root t. So here what will happen? So that can be written as Laplace transform of t to the power minus 1 by 2, right? So again here it is a fraction and negative, n is greater than, for n is greater than minus 1, we have again the same formula, that is gamma of Laplace transform of t to the power n will be, it is gamma of n plus 1 divided by s to the power n plus 1. So again here applying the same formula, it is gamma of minus 1 by 2 plus 1 divided by s to the power minus 1 by 2 plus 1. Now simplify this, gamma of minus 1 by 2 plus 1. Here we have gamma of n plus 1. When n is positive, we have gamma n plus 1 is equals to n into gamma n. So when n is positive integer, this gamma n plus 1 will become n factorial. Okay. But here negative, so first you simplify this term. Okay. So it is gamma of minus 1 by 2 plus 1 is 1 by 2 divided by s to the power 1 by 2. Again, what is gamma of 1 by 2? Gamma of 1 by 2 is root pi. Okay. So this value will be root pi divided by s to the power 1 by 2. Or we can write root s, okay, or together under root pi by s. So Laplace transform 1 upon root t is equals to under root pi by s. Okay. I hope it is clear to everyone. You have recalled your unit 2 till this, sitting at home, right? Okay. So stop here. Tomorrow I'll continue with the next, its properties and some theorem, okay, and based on problems. Okay. Thank you.